Welcome to this explainer. Okay, today we are going to embark on a bit of a scavenger hunt to discover the hidden code inside the totally mundane objects you interact with every single day. From the kitchen to the classroom, we are mapping the physical world.
But before we even dive in, do me a favor. Just look around the room you're in right now. Seriously, take a good look. Ask yourself, what is everything you see actually built from at the very most fundamental level? Like, what makes your desk different from the air you're breathing right now? I mean, think about a glass of plain water, a standard wooden pencil, or maybe a rusty iron nail. They seem completely different, right? But they actually all share a pretty remarkable invisible architecture. And uncovering that architecture is exactly what we're going to do today.
So, here's our roadmap for today. 1. Building blocks of matter. 2. Cracking the chemical code. 3. Navigating the periodic table. 4. Elements in daily life. And 5. The science of everything. Let's get to it.
Section 1. Building blocks of matter.
All right, so what exactly is an element? You can think of an element as the ultimate foundational puzzle piece of everything around us. It's a pure substance made of only one kind of atom. You literally cannot break matter down into anything simpler than this. Whether it's the gold in a ring on your finger or the oxygen we're breathing right now, these are the universe's ultimate building blocks. Section 2. Cracking the chemical code.
Now imagine having to write out the full names of every single element in a really complex formula. It'd be totally exhausting. So instead of writing out the full names every single time, scientists use a very specific abbreviated chemical symbol. The rule is super simple. The first letter is always capitalized, and if there happens to be a second letter, well, it's always written in lowercase. And honestly, for a lot of the first 20 elements, cracking this code is a total breeze because the symbol perfectly matches the name. Hydrogen is just H, oxygen is O, carbon is C, and calcium simply takes the first two letters to become Ca. It's highly logical and, very easy to memorize. But here's a little bit of fun trivia for you. Some of these symbols seem to just totally break the rules, right? Like, why on earth is sodium Na or iron Fe? Well, these actually come from their old Latin names. Sodium is from natrium, potassium from kalium, iron from ferrum, and copper from cuprum. And that is exactly why things like iron and copper look a bit confusing at first glance. Section 3. Navigating the periodic table. Now, I know you've probably seen the periodic table hanging on a classroom wall somewhere, but it isn't just a poster of things to memorize. It's an absolutely brilliant tool, arranged based on atomic structure and chemical properties. It essentially takes the total chaos of all known elements and puts them into an ordered grid that reveals the hidden patterns of how matter behaves.
To actually navigate this map, you really just need to grasp its two main structural directions. Think of it kind of like a giant spreadsheet. First, you have periods, which are the 7 horizontal rows going from left to right. And then you have groups, which are the 18 vertical columns going up and down. And there are exactly 18 of those groups. We're specifically highlighting the number 18 here because elements stacked in the same vertical column aren't just thrown together randomly. No way. They often share very similar traits, like how they react with other substances. So if you know how one element in a group behaves, you can make a highly educated guess about its vertical neighbors. Section 4. Elements in daily life. This is where it gets really cool because it's wild to think about how these abstract letters map directly onto your livelihood, your health, construction, even cooking. I mean, the carbon in your pencil lead is the exact same fundamental puzzle piece found in charcoal and, well, all living things. That calcium building your bones and teeth, found right on the periodic table. Iron builds our tools and nails. Potassium fuels our bodies and our farm crops. And copper is pulsing with electricity in the walls around you right this very second. And it gets even crazier when you take two distinct elements and combine their chemical reactivity, because you get something totally new. Let's take sodium, which is a highly reactive metal, and add chlorine, which is literally a toxic gas. But put them together, and their atoms bond to form sodium chloride, which is simply the totally harmless salt you put on your dinner. It's kind of like culinary magic, but really it's just fundamental chemistry at work. So as you can see, the elements are truly literally everywhere. You wrap your leftovers in aluminum foil. Every single breath you take is packed with oxygen. Every time you drink water, you're consuming a combination of hydrogen and oxygen. Understanding elements isn't just for scientists in white lab coats, you guys. It's for understanding the safe handling of household materials, knowing what's actually in the food we eat, and appreciating the very air we breathe. Section 5. The science of everything.
Ultimately, learning how to read the periodic table is actually just learning to read the blueprint of ourselves and honestly the entire world we interact with. It takes an incredibly complex universe and neatly organizes it by name, symbol, atomic structure, and chemical properties, making it so much easier for all of us to study and utilize matter. So, I'm going to leave you with this final thought. Now that you're armed with your very own chemical decoder ring, what hidden elements are waiting to be discovered right there in your own room? The next time you hold a pencil, take a sip of water, or even just turn on a light, I hope you remember the invisible foundational architecture, making the whole shebang possible. Thanks so much for exploring the building blocks of our world with me today.